Okay, we are continuing from where we left yesterday. When we stopped, I mentioned that we're going to carry on from dot product. Dot product is what is called scalar product. Now we're going to proceed and calculate cross product of two vectors. All together. Okay. Now let's do this. Let's say we've got vectors, two vectors like this. No, this is too small. Let me pick a slightly thicker line here. Let's say we've got two vectors. Let's say A there, and another vector. Let's say B there. Now, what is clear to all of us at the moment is that these two vectors are not parallel. Is that right? Okay. The two vectors are not parallel. Let me put this one this side. Now, we want to talk about cross product of two vectors. Now, when we talk about cross product of two vectors, we can, this is how we denote cross product of two vectors. Let's say we put A, we write A cross B. Now, before we go very far, please make it sink into your head that yesterday we talked about the scalar product, and when we did the product, it was a dot here, not a cross like this. And what we did, we got a number, a scalar. Now the answer of the product was a scalar. But today, we're talking a cross product. What we have here, we're going to get a vector. The result of this is a vector. And I think we mentioned that if we've got two vector, if we've got a vector A, you can also, we have got another vector associated to this, which is minus A, a vector with the opposite direction, isn't it? So, same thing here. If we've got A cross B, we also have got another vector B cross A, and these vectors, they've got the same magnitude, they only differ by the direction. Are we together? Okay. So now, I said the product of this is a vector. Right. Let me do this. Let me put this vector this way. Now, let's talk about, let me do this again and put a line here. We can talk about cross product in this way, or we can talk about cross product in that way. Now we can say A cross B or B cross A. How do we get it? Each one of these two is going to give us a different vector, but I'm saying the two vectors are what? Of the same magnitude, but opposite to the different directions. Now, what I'm going to do here, what I want to do is to start. I want to start with how do you calculate, how do you do this computation? So I'm going to get two vectors from two vectors in 3 dimensions. Then let's say A is equals to, I will use the unit vectors. This is that is not black, ne? Sorry, don't allow me to write in another color. I always want to write in black. For the simple reason that black is beautiful. I didn't say green is not beautiful. Minus J and plus 4k. So what I'm going to do, what I'm saying here, I'm going to start by the computation, then later I'm going to continue and see what is the interpretation of this, and then learn more about this cross product. So let's say B now. B is a vector I plus 2j plus 3k. All together. Okay. Okay. Now let me do this way and say and call this B cross A. I think I remember in physics. I think in physics there's something called the right-hand rule. No? Is that right? You must start thinking about that and see what similarity this has got with that. Altogether, yes, there's a link to that. Just let's wait and do the calculation first. So B cross A. This is what we're going to do. This is a determinant. I think now we can find the reason why we did matrices before we did this. This is a determinant. What kind of a determinant? Let's see. We put here a straight line. Oh, sorry. That's an arrow. I don't want an arrow. Okay. Let's see. Okay. Let me leave it like that. Then we put here I, unit vector I, J, and K. Those are unit vectors. Then that. Now what do you do? We take the components of B. Let's take the components of B. Just the coefficients of the unit vectors, in this case is 1 for this coefficient here. And then 2. And then 3. And lastly, we take the one for A. Then what we have here? 2 minus 1 and 4. Please guys, note how I'm doing this. And I said the other day I was talking to somebody in the passage here, saying this person was sort of telling me that, I think it was a she. She's telling me that I don't know, it sounded to me like she doesn't know what is important, what is to learn in class. But you must sometimes listen to me. When I normally say, in some situations, I just talk, but sometimes I pause and say, guys, this is something you need to know and then know how to do. In most cases, where I'm saying know how to do, there's a computation involved. Altogether. In this case, when I'm talking about this cross product now, at the end of the day, we must know what is the significance of the cross product. But you must also know how to compute the cross product of two vectors. Once you have computed that, the interpretations, what it means physically, those are the extras you must know. But to compute, you must know how to do. Altogether. So now the way I put the rows here, the way I put my unit vectors, the unit vectors there, the ijk, It's very important. You must know that we start with that. You cannot change this. You cannot put these J's and K's at the bottom, or you cannot put them in the middle. They always come in the top there. So you must know how to do. Am I making myself clear? I hope so. Because there's nothing as painful. You teach a student, then the student says he doesn't know really what is it to focus on. But I think all what I mentioned is important. Actually, there are some things I don't mention, which that's why you need to go to books and fill in the gaps. Okay. Now, this determinant is something we know how to calculate. I'm not going to, in this case, prescribe which method you want to do. But I'm going to use what I feel is the quickest thing to do now. What I'm going to do is 8. It's 8i. I'm right there, 8i. I'm not going to ask people what is 2 times 8. What is 2 times 4? Is that right? So we know that's a product. So it's 8i here. So next thing is 6j. But anyone who feels that is uncomfortable, doesn't know where that 6j is coming from, please shout. Then this is minus k. That is the sum of the product parallel to the principal diagonal, including the product on the principal diagonal. So then, according to how we calculate determinant now, you need to calculate to subtract the sum of the product parallel to the secondary diagonal, including the product on the secondary diagonal. So then we go for, listen, just for organization, I'm recommend that you do this thing. Look, I said 4, I stopped. For the sake of organization, I would recommend, which I saw the rule, I recommend that let's start with I and say I minus 3i. Is it? Then we start minus 3i. Anyone who doesn't know why I'm doing it like that, then that person is too young to be here. Plus 4k. Is that right? 4j. Oh, sorry, 4j. That's my mistake. Let's get rid of that k and say 4j. Isn't it? And then lastly plus 4k. This is just for organization. Now when you look at those things now, you've got your corresponding components almost on the corresponding position, then you can simplify easier, isn't it? So this is minus 3, that's a plus, that's 11i. 11i. Are we together? Then 6 minus 4. 2j. Then what follows there? Minus k minus 4k. Minus 5k. Are we together? Is that right? Okay. So that's the cross product B cross A. Now I'm going to invite you to do something a bit interesting here, because I want you to observe something, then we can maybe register in our heads some facts which are very important. Okay, maybe let me do this. I don't know what's happening there. I think the codes must be crazy. Okay. So let's do this. What do I want you to do? Let's do it maybe on the next page. What I want you to do now, I want to take this vector, and calculate, sorry. Can you listen please? Listen. Get this vector and calculate its dot product with A. and calculate its dot product with B. Can you do that quickly, please? Can we now listen, please? Now, we've calculated what? Let's start by saying, let's call this vector, let's give this vector name. Let's say this vector is C. Are we together? So now, I think, remember, dot product, when I say C dot B, that is the same thing as B dot C. So that's not a problem, is it? Why am I emphasizing that? Because I say these two things here are different, is it? I'm not, even yesterday, I never suggested that these two things are different. Altogether. So this one is the same thing. And this is a different thing. But same magnitude, but different. Now, this one is the same number. Now, what are you getting there? What's the answer? Right. You are getting 0 there. Now, I also said try C dot A. I'm not now going to say A dot C because that is obvious now. What did you get? 0. Yesterday, what did we say? What happens when the vector dot product is equal to 0? What is the interpretation of that? So in this case, we are saying C, vector C, is perpendicular to A. Same thing, C is perpendicular to B. So what is happening to C? C is perpendicular both to A and B. Am I making myself clear? Okay, so let's represent C there. Let's represent it C. C will be C will be positioned this way. That way. Then, in that case, everybody must understand that there's a right angle here between A and C. And there's also another right angle here between B and C. Actually, A and B and A, they actually generate a plane surface, like this, isn't it? So, C is what? Perpendicular to the plane, generated by A and B. I'm not writing that, but I think you can write that in your notes there. The beta C is perpendicular to the plane generated by A, vector A and the B. That is C there. Perpendicular will mean that it makes a right angle, isn't it? Yeah, half pi. Can I please have some questions if there's something there which you don't understand? Is there anything you don't understand? Okay. Now, listen. This is my practice. I don't normally want to tell people everything. I want to tell you people things at the beginning that this is going to call this is going to this. Once you start working, we know what we're doing. Some things I want you to do them. Then you observe what's happening, analyze the situation, and come up with a conclusion. Is it? Okay. Now what I want to do, I want you to do exactly repeat the same calculation. But in this case now, I want A cross B. Let's try to get A cross, no, this is not terms. This A cross B. We never call this thing a multiplication or something like that. We say it's a cross product. So we say A cross B. Can you quickly calculate that and give me the number, please? Do that in your notebook and give me the vector, the resulting vector. Now that you're used to this, I'm going to give you less time now. Okay. You must be joking. Okay, let's see. Who has got the answer? Volunteer answer. Yes? negative 1 minus 11i. Sorry, tell me the answer. Minus 2j plus 5k. That's good. That's correct. Now, my question is, what is your observation? Because that's what I didn't want to tell you. I wanted to do it, then observe and give me a conclusion. You see that A cross B is actually equal to minus B cross A. Now, if AC is going up perpendicular to the what? To the plane. What about this one? Down perpendicular. In other words, now this is what is going to. This is what we should visualize. This is what we should visualize. This is what you should visualize. Let me take a different color so that people can see properly. This is what you should visualize. You must have. Oh, let's see. You must have something like this. Perpendicular. All together. So now, if let's say if we call this one C. I know why C. Let's just get another name. There are many letters here. Let's call this one D. So D is facing down like that. But both of them, they are perpendicular to what? To the what? To the plane. All together. Okay. That's good. That's good. That's nice. That's good and nice and nice. That is good and nice, isn't it? Good is nice. Yeah. Okay. So one thing we should have learned now is that A cross B is different from B cross A, but joining the two, they are both perpendicular to the plane. They both have got the same magnitude. Are we together? Okay. I'm going to continue here. I want to show you something. I'm going to continue. Let's do this. Can you write down the vectors? Please write down the vectors C and D somewhere on your. Write them down because we're going to use them. You have them. Good, man. This is vector C. What's happening? Let's do this. Right. Let's keep our vectors there. This is A cross B, and this is B. Sorry. What has happened? There's something wrong has happened. Eh? What happened? There's an A there. Okay. Let's just erase this. Okay, what is this K? Eh? And now guys, these are the two vectors we got, B cross A and A cross B. Okay. Let's do something interesting here. Let's get this vector, and what I want to do with that vector, I want to copy it. and paste it somewhere. There is the vector. I will take it this way. What is that? That vector must be parallel to the original one, isn't it? Because it's the same vector, isn't it? Okay. Okay, that vector there is parallel there. Oh, sorry. Anybody at grade 12 will tell me what that shape is. What is the shape? It's parallelogram, isn't it? And that as a parallelogram is a plane shape, it must have area, isn't it? How would you get the area of this parallelogram? Half base times. How do you calculate the area of the parallelogram? Sum of the two parallel sides times height. Sum of the two parallel sides times height. Is it half or is sum of the two parallel sides times height? I'm asking you, I'm not telling you, I'm asking you, is it sum of the two parallel sides times height or is half the sum of two parallel sides times height? Come again? Half the sum of the two parallel sides times height. Are you sure of that? Okay, let's see. Now, before we get there, let's recall vector A on its own, please. Let's get vector A on its own. You've got it there. Tell me what's vector A. Remember, vector A is this one. What is vector A then? 2i minus j plus 4k. B equals to I plus 2j plus 3k. Right. Can I ask for the magnitude of A? Please calculate it and tell me what's the magnitude of A. And also calculate what's the magnitude of B. I hope if you calculate the magnitude of A, you must be able to tell me what does it represent. What does it represent, the magnitude of A? The magnitude of A, what does it represent? Isn't it supposed to be the length of the vector? The absolute value of the vector, isn't it supposed to be the length of the vector, the magnitude? But then in this case here, we've got a parallelogram. What does it represent? The length of the side of a parallelogram. I'm asking, what does it represent? You get the magnitude. We've got a parallelogram. You've got the magnitude of A. What does it represent? It represents the length of the side of a parallelogram. Do you agree? Do you agree? Okay. But I get a funny feeling when you can't answer simple questions. Then I think maybe there's something wrong I've said somehow. Right, guys. From what I heard before here, I'm sure that you are not sure about the area of what? Of a parallelogram. So I'll just say, no, God bless for that confusion, but let's do what we're supposed to do here. Let me draw a parallelogram which we are all used to, because maybe this one is skew. Then let me get this. Well, this is the side which is parallel to that. Now, let's do this. That's the other side. Then maybe let's I just want to draw a paragraph which you can understand here, so because I can see that I've got a serious problem here. I cannot continue with such a kind of problem because I'm going to talk the language people don't understand, and that's not good. That's hard. Then let's get this one. And this one is the other side. I think this is a parallelogram which you are used to because this is how they draw the parallelograms in the books used at school. God bless them. Now, what I'm trying to show you, just to show you that what you did there is wrong, is that if you drop a perpendicular here, you might as well drop a perpendicular there. And this right angle is the same right angle. Now, if you transport this segment, it will be the same segment there. Let me pick my black ink maybe. It will be the same segment here. So now, the red side here and the red side there is just the same one transported there, the top of it. What you are left with here, you are using the red line here and forgetting about the slant. And this slant, this one, has been transported to there. You have got a rectangle. So, because I think because of this word base, so you want to see it sitting on the base. So this is the base. And then this is the height, which is the distance between the two parallel sides. At the end of a good day and a good discussion, this is not different from the area of a rectangle. It's just base times height. Because what is a rectangle? What is a parallelogram in this way? It's just a rectangle which has been pushed slant like this. All together. If you didn't see that at school, it was unfortunate, but you have seen it today, thanks to the gods. So, at the end of the day, area of a parallelogram is equal to base times height. And normally height, when you talk of height, perpendicular is inbuilt. All together. It can't be height when there's no perpendicularity. All together, guys. Okay. So now, what is my reason of asking for this modulus? Because I want the length, because now the base here will be A. That will be the length of that vector, which is generating that parallelogram, isn't it? And that one is the same thing. So now, what is the length of AB? What is the length of A? Square root of what? Square root of 21. I don't need a calculator. Yeah. And the P? Square root 14. 21. My friend, this is not a Stumo show or something like that. Don't turn this into a circus. Are we together? So we can take this as base. Indeed. Now, check. To get that height, sorry, guys, to get that height, where were you when we were talking about this thing? When I was writing this, where were you? No. I said when I was writing this, where were you? That's not good. That's not good. Let's not continue there. If I ask you to do calculations, remember asking for the calculations, everybody must be attentive. If there's a mistake, one should check the result of the other, isn't it? So don't check 10 minutes later when I've written something there. It's not good. Alright. So that is root 14, are you sure? Listen, it's you who gave me this thing. I asked the class. I will ask exactly the same question to you. Where were you as when I was writing that 21? I didn't do the calculations myself. I asked them from you. I said, guys, give me the result. Okay, it's 21. Okay, it's fine. Can we proceed? Can we proceed? Sorry, you are making us this direction there. Let's proceed. Now, to get this height, h, we need this angle. Because we've got this length, which you can tell A or B. Is that right? We need this angle. If we use our base as B, then this side is A, isn't it? So to calculate, if we just choose our base to be B here, then the other side will be the hypotenuse there in that triangle, isn't it? So we must be careful what we use. So now to get this H, what can we do? Opposite over the hypotenuse, sine that. All together? Why are you shaking your head? My friend, this is a right angled triangle. This is a right angled triangle. What is your problem? If you've got a right angled triangle, you want the, because we said the area of this parallelogram will be calculated by base times height. So we need that height. How can we get it? Okay. This is not the question that you don't understand. You are not paying full attention. So that you can say now sine theta equals to what? H, yes, H over the modulus of A. Are we together? That's H over modulus. Then therefore H is equal to modulus of A sine theta. But what is theta? What is theta? Theta would be the angle, this angle. That's the angle between A and B, isn't it? So it can be calculated, isn't it? So let's not worry about calculating this one, but let's just note that it can be calculated. You agree with that one? Okay. So now what is the area of this parallelogram? The area of that parallelogram will be B multiplied by absolute value of B multiplied by absolute value of A times sine theta. Are we together? Now, I'm going to leave this one as homework for you. Go and calculate that angle, evaluate this, and check that this is equal to, I'm telling you this one, you must check that this is equal to the modulus of B cross A equals to modulus of A cross B. I don't want to do that thing now because it's going to take us a little time, but I'm just advancing you that. Go and calculate that angle, evaluate this area, and then check that these two are equal. Maybe you might need a calculator here, maybe here you get a number, decimal number, then here you just get with the square roots, then maybe use a calculator and see that they're equal. But the fact of life which you're going to register now there, you can write it as a note. The parallelogram generated by these vectors A and B here, he has got an area. This is what I'm saying here. He has got an area. That area is always equal to the modulus of this vector, which is A cross B or B cross A. As a fact. Are you writing it down? Write it down. That will save your memory, because one of the poorest things God gave to human beings is the memory. Things don't last a long time in your memory. Come again? Should I rephrase what I've just said? First of all, let me ask you a question. Do you notice that here we have now got the area of a parallelogram? According to what our discussion here. Yes or no? You have calculated this magnitude of A and magnitude of B. You're going to insert them here, and then this area, this angle from yesterday, from the scalar product, this angle can be calculated using the scalar product, isn't it? So I'm saying go and calculate this angle using the scalar product from what you learned yesterday, then insert it there. you get a value there. Obviously, because this is sign, you get this value in in maybe decimal. But I'm saying after that, check these two vectors, one of them, not two of them, just one of them. We know that their magnitude are equal. Just take one of them, calculate the magnitude, compare that magnitude with this area we got here. I'm saying the result you must expect that they are equal. Now, fact of life to write down there. If I've got two vectors A and B, they are not parallel. Naturally, they are going to generate a parallelogram. Altogether, a parallelogram which is on the plane, which is generated by the two vectors. Any two vectors are not parallel like this in 3 dimensions. They have generated a plane. So that parallelogram is that on that plane is got an area. The fact I'm telling you, I've claimed here that these two numbers here must affect them equal. What am I saying? I'm saying two vectors A and B not parallel, they generate the parallelogram. But the area of the parallelogram is numerically equal. I'm saying numerical equal to the magnitude of the cross product vector. Whether I say B cross A or A cross B. Did I rephrase it nicely? Did you hear that? So, when it's asked for, please recognize it. I said write that note down there so that you save your memory. Because memory will not always keep that for you. But your notebook will always keep for you. When you forgot it, you go back until it's part of your system. Are we together, right? Yeah. So let's at this point little bit summarize what we have done. I mentioned yesterday that we're going to deal with cross product. We've defined the cross product. We've seen how it's computed. So you must know what is cross product and how to compute a cross product of two vectors. Now we're giving some interpretation of that. We're saying, okay, cross product vector is always perpendicular to the plane generated by two vectors, but the two vectors also generate a parallelogram. And the parallelogram is got an area. Now the length of the cross product vector, the absolute value of that vector is numerically equal to the area of that vector. All these things I'm talking about calculations here. If those are calculations, you must know how to do. Any questions? Why the unit vectors have got the same direction? No, I'm listening. I'm sorry. I don't understand what you're saying. What I'm saying?
You take vector A.
Yeah.
So it's projecting those vectors I, J, and K.
Vector A is made up of multiples of I, J, and K. Now they are components. Is that right? Components in the direction of X, components in the direction of Y, components in the direction of Z. So what is your question?
So the way they were indicated, they were predicting that they were also equal.
No, then which on top are you talking about? Yes, they're vectors. They're unit vectors. What? I don't know. I don't know whether you. Yeah, vectors. They're unit vectors. Yeah. I've got 3. This component says 2 times unit vector plus, because it's a vector. Look, when I move in the direction of X, it's a vector. But how many units do I move? I move 2. In the direction of Y, I move 1 unit in the negative direction. So they are vectors. There's no problem without that. They are vectors. If you didn't understand them like vectors, then I would have a very serious problem. I don't know, maybe I'll be standing on my head or something like that. I don't know. Yeah, good. Any other question? Okay, so guys, I think up to this point, I'm going to stop here and say thank you for listening. The next task is to look at what are the few physical applications of this thing. Obviously, I'll give you the few. Remember, the task of a teacher or a lecturer is to teach the students ABC, and the students must find their way up to Z. So I'll give you examples, then you must then explore the world and find where you can apply this thing further. Thank you for listening. That's the voice of Charles Sugasfani Mube.